So our next speaker is Antti Aronen. He is a senior research engineer at Clarkson here in Finland. He has more than 15 years experience in the research of the flat glass heat treatment process. And his main area of interest is the modeling of the deformations and stresses in the heat treatment process. Please.
Thank you, Simon, and welcome everyone. My topic today is to tell you a little bit about the convective heat transfer and what are benefits in that one for automotive windscreen and sunroof production. And my target is that after this presentation you get idea what are the benefits in convection and how that can be good for automotive production, automotive windscreen production. At first, one question: how many of you have automotive bending line or are thinking to buy one? Yeah, a couple of ones. That's good. So this is especially for you to get some ideas what are the benefits in this. So we will show that convection preheating will solve some of the problems what you have in with the radiation preheating. And if we at first start with showing what has been changed during the last 20 decades or so. Earlier in the 90s, cars were looking like this, and especially if you are looking at the windscreens, those were smaller ones, those were more flat, and there isn't the painting around the glass. So that those glasses are quite simple, and those were good to be processed with the radiative heat transfer. But nowadays, cars are looking more like this, and windscreens are more complex. There is especially wider painted areas at the edge. Complexity is different. There are advanced driving systems which helps you to get the information about the surroundings. And all those things makes this glass processing more complex. But with the problems what we have previously got with the radiative heating, we can now solve with the increased convection. Some of you have seen automotive windscreen bending line. There on the right side, or on your left side, there is a preheating part, which is my main thing where I will concentrate today. So in that part, the idea is that the glass is heated up to 500 degrees, and the target is that after preheating part, glass is at as uniform temperature as possible. What we can do to do it quickly and make good for bending process where the main bending has been done. So when the glass is around 500 degrees, glass is still staying flat. It doesn't bend that much. But when we are going to bending part and the pressing part, glass is heated to around 620 degrees, and then the bending is faster, and we can get right shape in windscreen. After glass is heated, bended, glass is going to annealing part, where this cooling is controlled so that we can get the right stresses in the glass, so that we can avoid the unwanted breakages, say during process or in the use. And at the end, the normal cooling part, so that we can at the end handle the glass. So why this 500 is good in our mind? So we want to, in preheating, heat that glass so that we get up to 500 degrees. Glass is basically around the 500 degrees plus minus 20 degrees. And then you can see that at that point, there isn't really bending speed for the glass. But when we go further in bending part, the glass temperature is 620 degrees, 630 degrees. And if there are in preheating part, you get some places in the glass. In one area, there is a 500 degree area, and another place is at the 550 degree area already. And then you go to a bending part. It can be that your target is to get glass to around 620 degrees, but at the end, some parts are going up to 640, 650 degrees, and that makes problems in your process. So that's why preheating part is important, so that that makes bending part more easier to solve. So here is how we have solved this one, how our convection heating part is looking at. So this is one of the chambers in convected heating. You saw before that there might be, depending on the line, 5 to 10 or 20, even just depending on how much production you want to do with the what base. Here's one animation where we can see a couple of advances what we have done. Basically, there are heating elements at top and bottom to get the heating done. But we have put cover on top of those heating elements so that you don't get straight radiation from the heaters to the glass surface, but there is some metal sheet in between to balance this radiation. And at the same time, there is air is going to blower, and it's circulated to air channel, which is going through or where these heaters are. This air is heated, and then when it's coming out from the hose, which we call, in this case, nozzles, then it's blown on glass surface. And that way we can get this convection. We had to reduce a little bit the radiation, but we can, with increased convection, get the benefits what we want to get from this process. I will show this animation again. You can get maybe better idea after my words. So there are still heaters, but those are covered, and then convection is added, circulating air. There is not too much energy consumption in that one, but we can, with convection, this heat transfer on the painted areas and the clear glass areas are more balanced. Why we choose to go with the convection? There are also other heat treatment processes like flat tempering. When coated glasses came on end of last century, beginning of 2000, there was a problem that heating on the clear glass side and the coated side were different. So we increased the convection on the coated side to balance the heat transfer on both sides. Same thing with the flat lamination, coatings, paintings, glass sizes, new interlays. Those needs balanced glass temperature around the glass area, and to make this heating so that the heating so that the glass has a uniform temperature during the process. We increase the convection to make this uniformity better. And also the controlling of heat transfer. And now in the windscreen bending, because of coated glasses, painted glasses, and there's also bending tool which makes effect in the heat transfer. With increased convection, we can now do this heating part more uniformly to get better results for the end result. Like here is one example. There is a part of a windscreen. There is white painting, 10 centimeter wide area. And heat transfer in these areas and clear glass areas in heating with radiation is different. Here is an example. Green lines are with the low coating, and the black lines are with the radiative heating. So if we are looking with convection, you can see that this temperature difference between painted glass and coated glass is just at the end maybe 40 degrees. So it's good comparing to what we get with radiation. Now at the end, when we have reached on the lower side to the same temperature as with convection, now the temperature difference is 60, 70 degrees. And we want that, as I said before, we wanted that this temperature after preheating should be more uniform to get better end results after bending. So here is same curves, or same results, so that you can see better that what's the difference after heating, what's this temperature difference. So we can change from the 70 degrees down to 40 degrees according to calculations. Yes. And some things what we can help with this one is one visual effect called the burn line. It's you can hear maybe whiter and darker areas. So this is a test case where we have a light source on one side, then a windscreen in the middle, and we are looking the shadow of the windscreen, what's coming from that one. With that test, we can find that if there is some problems, like in this case, this burn line, which cause defects in the visual quality and optics. And problem in this one has been that the painted area at the edge and the clear area in the middle, those are heated at a different speed. And that is causing a thermal strains in the glass, which are at the end seen as visual faults. Or if there is a different kind of bending, that's also seen in a similar way. Another example for testing that what's the end quality is that to compare what is the shape of the glass to a target shape. And in this one, orange areas at the edge, those are showing areas where bending has been too big. So glass has been bended during the process too much. And blue areas are the areas where glass has bended too little comparing to target. And as you can see, red areas are at the edge, and that's typically a reason for that the edges are with coated areas, painted areas, and those has been heated to higher temperature than wanted. So those should be avoided, and that's why it would be good to balance this heat transfer at different places to get more uniformity in the glass. And there are also some modern features in the glasses, windscreens, which need even more better optical quality. One example is head-up displays. So these are areas in front of the driver where driver gets information what's happening in a car or around. And in that area, the optical quality in the glass should be good to get the right kind of image from a projection. Another example is these advanced driver assistance systems. So this is area in the middle of the windscreen, on top of that. And in these areas, there are typically cameras which needs good optical quality for the glass so that you can get the right image in a camera, so that there is no optical defects in the image what they are looking. So those are things what are coming, and more also other new features are coming, and to avoid the problems in windscreen bending which these are causing, or which we should avoid. That's why convection heating is a good thing. So that's one of my results. But there are also a couple other benefits what we can see. This, what I saw before, that's main thing, and the main thing where we have been focused, but there has been also other ones which are coming on side. One is related to heating speed. With the convection, we can increase heat transfer, total heat transfer. So total heat transfer is a combination of radiation, what is coming from heaters and surfaces to glass surface. Convection is heat transfer, what happens between surrounding air and glass surface. Then conduction is what happens in the glass, and contact heat transfer, what happens between contact points between frame and glass surface. And we can say that with combining this convection to radiation, we can increase the total heating effect. So, like in these results, green line is with convection, and the red one is with radiation, with the same heating time. So we can see that with convection, we have been able to increase the heating rate, and that way we will meet the target temperature in faster than with only radiation. And also, if we want to get the same end temperature, in that case, we just have to increase the heating time for radiation. So we can save some time in processing by adding this convection. And this is also leading to that one that maybe we can make automotive line shorter. We don't have to use so much or so many preheating chambers in the process. So that was one extra benefit for convection, that we can increase heating rate and decrease the heating time. And the second one is related to energy consumption. One thing is related to a topic what I just mentioned, that we can make a line shorter. And when we make a line shorter, we have less wall area in the process, and we can reduce the heat loss, and that way save in energy consumption. Another thing is how we use the bending tool. We always have to put glass on a bending tool, heat that also in the process to get the right shape at the end with this specific bending tool. And sometimes with the radiation, you have to use this kind of heat absorption plates to balance the heat transfer between painted areas and clear areas in radiation heating, just to avoid the big differences in temperature. And in this one, for example, is lots of steel. If we are using 10 kilograms of steel, that means that you have to use 1 kilowatt hour per each loading. And if you are doing like 500,000 glasses per year, and the energy price is like only 10 cents per kilowatt hour, then you can save 50,000 euros per year just for energy consumption. So with adding a convection, we can use much simple construction for this bending tool, and we don't have to use so much energy for heating just bending tool, because the main target is to heat only this glass, but the bending tool is coming on the way. So we can reduce energy consumption also in with this convection preheating. So my conclusion is again that convection preheating solves problems in automotive windscreen and sunroof production. And I show you some benefits, and now you should think about when you are buying a next line that maybe that would be a good idea in your process. Thank you.